Welcome everyone, and thank you for being here today. My name is Zoltán LOVÁSZ, and I am a PhD student at John von Neumann University. Today, I'm going to talk about a very critical topic, the ontology and diagnostics of prudential data quality in the European Union banking system. Since the 2008 global financial crisis, the stability of the European banking systems depends less on physical assets and much more on the integrity of its information infrastructure. However, creating a perfect IT system is not enough. My goal today is to show you why traditional IT methods are no longer enough to measure data quality and how we can use new diagnostic approaches to find real, hidden risks in the banking sector. Let's begin. Let's start with the paradigm shift in the banking industry. Before the 2008 financial crisis, data was often seen as just an administrative footprint. Today, the reality is different. When establishing the theory of economics, Laney pointed out that data is a strategic asset with measurable value and distinct life cycle. The collapse of Lehman Brothers taught us a painful lesson. When data is fragmented across inconsistent formats, decision makers are flying blind, turning banks into opaque boxes. The core problem we face today is this. Our static, traditional data quality methods fail to meet modern prudential expectations. Having data that is technically correct in an IT system, which we call syntactic accuracy, does not mean it is correct for the business or the regulator. What we truly need today is semantic consistency. Concepts like loan or collateral often mean completely different things in legal, accounting, and risk management systems. So, why do IT systems still fail despite billions of euros in investment? To understand this, we must look beyond engineering and use organizational sociology. First, there is the concept of decoupling, developed by Meyer and Rowan. Organizations under intense regulatory pressure often create formal rules, like appointing data owners just to look good for the regulators and gain external legitimacy. But in reality, business decisions are still made informally, using manual spreadsheets. Second, we have the agency problem. Inside the bank, there is a fundamental conflict of interest between the principal, like risk management or the regulator, and the agent, which is the IT or business line. This creates the famous watermelon effect. Data reports look green and compliant on the outside, but they are red and critical on the inside. Third, the ontological deficit. This happens when the IT system simply fails to map what is actually happening in the real world. Regulators have realized these problems, and the pressure on banks is growing. The BCBS 239 standard was the first major step. It is basically the constitution of risk data aggregation. Now, in the European Union, the ECB and EBA are pushing forward unified dictionaries like BIRD and the new data point modeling 2.0 framework. A huge innovation of DPM 2.0 is modularity, which sharply separates structural data definitions from business validation rules. The ultimate goal of the ECB is the integrated reporting framework, which is based on the define once, report once principle to reduce redundant reporting burdens. Furthermore, the newest EBA guidelines have zero tolerance for silent corrections. Banks must immediately correct their reports retrospectively for at least one calendar year upon discovering faulty data. They cannot just quietly fix all data anymore. they must adopt bitemporal data management. This regulatory pressure creates a huge technological paradox, which we call the two-speed data management problem. During peacetime or going concern, banks focus on historical consistency and accounting, usually with monthly reporting cycles. But in a crisis or gone concern, the single resolution board requires a full valuation dataset covering the entire balance sheet within exactly 24 hours. This is the paradox: speed versus accuracy. According to Hornager's resilience theory, in a crisis, we cannot wait for perfect accuracy because it causes decision-making paralysis. We must design resilient systems that can provide just-in-time estimates under extreme stress. If data is missing within this 24-hour window, independent valuers are forced to apply buffers for uncertainty, which results in unjustifiably high haircuts for creditors and shareholders. Moving on to modern architectural threats, you probably know Conway's law. IT systems automatically mirror communication structures of an organization. Because banks have organizational silos, they naturally build fragmented data silos. Furthermore, as banks use more artificial intelligence, we face a deeper structural danger, the entanglement risk. Traditional banking IT relied on deterministic logic with strict if-then rules. But modern machine learning models introduce probabilistic operations. These models have soft dependencies. They depend heavily on the statistical distribution and the semantic meaning of the data. If the underlying business concept evolve, which we call concept drift, the AI model skews silently. We call these silent failures. The IT system shows no error, but the business decision becomes completely wrong, creating severe information asymmetry and systematic mispricing. How do we solve this fragmentation? We need to move away from centralized data silos, which often become a bottleneck. One modern answer is the data mesh, a decentralized, domain-oriented architecture. But to make this work safely, we need data contracts. These are machine-enforceable agreements between different departments. If a source system changes its field structure and violates the data contract, the pipeline automatically halts. This technological break prevents anomalies from leaking into Prudential reports. We also need to implement knowledge graphs. These graphs organize federated data into network structures, rendering business rules machine-readable. This helps prevent AI hallucinations and detects anomalies. Finally, with the new DORA regulation, protecting this data infrastructure through threat-led penetration testing is no longer just an IT issue, but a fundamental prudential requirement. So, how do we measure if a bank is actually managing data well? The European Central Bank now uses the Data Quality Indicator framework, and the poor score can trigger additional capital requirements, or P2R, as a punishment for high operational risk. To avoid this capital punishment, traditional audits using binary yes or no questionnaires are useless. As we saw with the watermelon effect, people just tick yes to look good. In my research, I propose a new diagnostic methodology based on the deep dive principle. Instead of just asking if a data owner exists, we must select a critical regulatory report at random and trace it backward to its source. We must use evidence-based measurement. This means comparing the formal approvals with the actual audit trace in the IT system. This is the only way to expose ceremonial compliance and true operational risk. Based on this theoretical framework, I have three practical recommendations for bank management. Number one, build a transparent architecture that makes silent corrections technologically impossible. Replacing legacy systems is a prerequisite for clarifying responsibilities. Number two, give real veto power to data owners. They need actual decisions rights to counterbalance business pressures. Also, their performance KPIs must be directly linked to data quality to stop the free rider behavior born from the agency problem. Number three, ensure quality at the source. We must stop doing manual corrections at the end of the reporting process. We need automated system controls that enforce compliance with EU regulatory concepts like the Bird Dictionary right at the moment of data entry on an ontological level. To conclude, true prudential data quality in the 21st century means far more than synthetic accuracy. It requires semantic consistency and crisis resilience. We cannot fix our technology without eradicating the culture of organizational decoupling first. Looking ahead, my future research will focus on extending these diagnostics to ESG data. The new CSRD directive is pushing banks into a new universe full of unstructured data and a severe ontological deficit because terms like green or sustainable are currently inconsistent. Mapping the lineage of climate transition risk will be the next unavoidable frontier in bank data management. Thank you very much for your time and your attention today. I look forward to any questions you may have.